Geometry, Unit 7, Section 6. 3 parallel lines, 2 transversals, 1 proportion. This is another instance where we're just going to see some proportions created, common ratios and a lot of cross multiplying. The previous lecture video was about the angle bisector theorem, where we created a proportion to find missing lengths. And we're going to see something similar here. Now, the angle bisector theorem did not create similar triangles, but the reason why this works is because of similar triangles. So this does. It's not mentioned here, but these horizontal lines are all parallel to each other. It should be mentioned here. And since these are parallel, if we just focus on, say, this triangle in the middle here, this one right here, we see that these lines are parallel, and so that must mean that this is a similarity happening in here. That this small triangle is similar to this large triangle, because we know this is a reflexive angle they both have, and if these lines are parallel, then these are corresponding angles of parallel lines, and so are these, and so all the angles are congruent. So this is creating similar triangles here. And so what that means is, we know from the side splitter theorem that the ratio of x to y here and here must be equal to the ratio of a to b, because of dilations and similarity, and so we know that to be true. Then we have another triangle that we could take a look at, and that triangle is here. I know you probably don't have the ability to highlight the same way I do, or if you have highlighters, you can use them on your notes. But take a look at this blue triangle. The fact that these sides are parallel here means that we have a similarity happening in here. This tiny little triangle is similar to this big blue triangle, and therefore we get a more proportion, again, because I have a reflexive angle between the two, and if these are parallel, and these are corresponding angles of parallel sides, so these little triangle and this big blue triangle are proportionate. That means that the y to x, or the x prime to y prime over here, x prime to y prime, is proportionate to the a to b on this side. And since x over y, or the ratio of x to y, is proportionate to a to b, and the ratio of x prime to y prime is proportionate to a to b, therefore xy, the ratio of xy is proportionate to x prime y prime. And really what this is trying to show us here is that I can work with these sides here, that these two are proportionate to these two. And even though they're not really piece of the same triangle, however, if you could extend these transversals all the way up, wouldn't that form a big triangle? So they could be kind of thought of as the same triangle. But basically, if you have multiple parallel lines with multiple transversals, the segments that are interior of the same parallel lines on different transversals, they're going to be proportionate to, the segments of other pieces on other transversals. So again, we're just going to see some proportions. Let me show you just one quick example of what I mean. So again, there's really no triangle here, although we could extend these lines to create one. But you see that, again, these three lines are parallel, and 9 and 3 are on this transversal over here. 12 and x are on a completely different transversal over here. However, the ratio of 9 to 3 is going to be the same ratio of 12 to x, because of what we're really seeing over here, that I can think of a triangle here, and I can think of a triangle here, and set them equal. So these are different transversals, but basically a transversal is segmented by multiple parallel lines in a proportionate way. That no matter what angle the transversal hits, like this angle is not congruent to this angle. These transversals are not intersecting the parallel lines the same way. But however this transversal intersects this parallel line, the ratio of the segments it creates, it's going to be the same ratio of this. So, I can make a really a really long one, you know, like this, and what you'll see is that this is getting really long, but so is this. Or I can intersect at a different angle like this, and so this is much shorter than this, but this is also shorter than this. So the transversals intersect the parallel lines in the same proportionate way. So very simply, we can create a proportion of 9 to 3, and you could probably do this one in your head, is proportionate to 12 to x. And so we can certainly cross multiply 9x equals 36 and x equals 4. But we see this is a 3 to 1 ratio, so this is a 3 to 1 ratio, and so that's basically it. So this is just showing that parallel lines with different transversals, it creates any, it segments any transversal in a proportionate way. And so we can create proportions and solve for segments like that. All right, so that's it. Real short and sweet.